Let your dreams be bigger than your fears, your actions louder than your words, and your faith stronger than your feelings. Honorable Chief Guest of the Day, Pratap Kumar M.S., respected dignitaries, guests, delegates, and all the participants. A very good evening to one and all present here. I, Bhagyashree, feel privileged to welcome you all to the 61st talk of the Intersociety weekly webinar series, jointly organized by IEEE Kerala Section, the Institution of Engineers India Kerala State Centre, Computer Society of India Trivandrum Chapter, PMI Kerala Chapter, Internet Society Trivandrum Chapter, Vakkom Moulavi Foundation Trust Trivandrum, IEEE EMBS Kerala Chapter, and IEEE Life Member Affinity Group Kerala Chapter. Since their inception as a means of providing electronic device during the criminal investigations, electronic security systems have come a long way and are now widely recognized as a major deterrent to crime. Electronic security has evolved from analog wired systems to digital systems, resulting in a more precise, compact, and user-friendly service that can be easily installed and monitored, even from handheld devices. Overall, these systems provide peace of mind to human resources and assets by ensuring their safety in a secure environment. Before we begin, I would like to kindly bring your attention to the feedback link that will be provided during the session. Kindly fill the form and let us know your opinion. Also, please do not hesitate to mention if there is any requirement for the certificate of attendance. So, moving on to the formal session, I invite Mr. Gokul, IEEE volunteer, to welcome the virtual gathering. Gokul, are you here?
Yes, I'm audible.
Yes, you're audible, Gokul. Thank you. Please go ahead.
It has become appallingly obvious that our technology has exceeded our humanity. Good evening, everyone. I warmly welcome all of you to the 61st webinar of Intersociety Weekly Webinar Series. The topic for today's webinar is Evolution of Electronic Security System. To talk about this topic with immense pleasure, let me welcome Mr. Pratap Kumar M.S, Senior Team Leader Security and RFID Projects, Reliance. Welcome, sir. Next, I would like to welcome Jamanlal sir from IEEE and all other eminent personalities gathered here to this session. I also welcome Bhagyashree IEEE MC for today's webinar and our Zoom controller Gifty Pichaju. And at last, I want to welcome all the attendees who are eagerly waiting for the session to begin. I warmly welcome you all.
Okay, thank you, Gokul. Next, I humbly welcome A. Chandrakumar sir to introduce our esteemed speaker. Sir, please.
Hello.
Yes, sir, you're
audible. Audible.
Thank you. Yes, sir. Thank you.
Okay. I would like to introduce the speaker of the day, Mr. Pratap Kumar M.S. He is a close friend and a classmate of mine. He passed out from College of Engineering Trivandrum in 1984 in electrical engineering. He is having a different profile in different areas. He worked in Bajaj Electricals as a project engineer and a senior project engineer, executed lighting projects for important infrastructure projects like IL, NDPC, Mumbai Airport, etc. Later, he moved to AEG NGF, now known as GE Power Controls Limited, and was a team member who worked for the electrification of the INS Mysore, a naval warship of Mazagon Dock in Mumbai. In 1998, he joined in datametric security systems and entered the field of security systems and executed various security system projects. Notable organizations such as Indian Oil Baroda Plant, IG Mint, Kolkata, Reserve Bank of India, Mumbai, and GAIL Baroda, etc. Since 2006, he is with Reliance Industries and heading their security system and RFID projects. Today, Pratap will be talking about the various types of security systems, their technology challenges, and also the size of the global market of electronic security. He will also introduce us to the main players in this industry. He was born and brought up in Trivandrum, that means heart of the Trivandrum city, and he was the eldest son of the film director late Sri Sukumaran Nair, who was famous during in film direction 1980s and 70s and 80s. He's a good singer of our batch who used entertain us during our class meets and get together. He is having a good organizing skill, which is proven on organizing various events. Overall, He is a good human and good friend to all of his friends. Now I am presenting Mr. Pratap Kumar to you. Thank you.
Thank you.
Sir. Okay, without further ado, let me hand over the session to our beloved speaker, Pratap Kumar, sir.
Thank you very much. First of all, I'd like to thank the organizers for this event for giving me this opportunity to speak on security systems. Jamanlal sir, Haridalal sir, and so on in particular for the guidance and support. Gokul, Bhagyashree, and Chandra Kumar for your introduction. And last but not the least, to all of you, dear friends who have taken time out of your busy schedule and logged in today. A warm welcome to you all. So I'm starting my presentation, sharing my screen. Sorry, is the screen visible?
Yes, sir, it's visible.
Okay. So we are going to talk about electronic security systems. So the electronic security systems basically are considered to be the extended arms and eyes of security personnel. A lot of inputs regarding electronics from electronic systems have helped this personnel to do the job more effectively and efficiently. So from a design point of view, initially the systems were designed to help these people, but over a period of time, with the advancement of technology and other areas which help security system to reach a level that they have almost replaced this physical security personnel, and they can handle security of sites independently. So this is the background on which I'll be talking about. So I'm going to start my screen. So a small index about what we are going to speak about. We'll be starting off with a little bit of history about security systems. We will be then moving to the major categories or the types of security systems. From there, we'll be talking about market size, global market size of security system markets, the main players who are involved. Then a hot topic of today is privacy concerns regarding security system. We'll be discussing a little bit about it. And finally, the future or the road ahead, what is in store for us in the security systems market. So if you look at the history of mankind, traditionally human beings were very much concerned and gave a lot of importance to security. The people, when we were in the Stone Age and people were living in caves, we developed these type of fences, which you can see in the diagram, to protect ourselves from wild animals and from fellow beings. Later on, the concept of doors took over.
Hello.
Hello. Later on, the concepts of doors took over, and doors with locks came into existence. These doors were again guarded by security personnel. And this concept of security remained for a long time, for centuries. And the major breakthrough came in 1752 when Benjamin Franklin invented electricity. Mankind came to know about the immense possibilities of this new source of energy and the ways and means it can be put to operation. And security systems also geared up for these type of changes. And one of the pain points in security system because there was if somebody faces a situation as a breach of security, there is no way to give an alarm and to alert neighbors of what is happening and get the support. So the first electrical security system was invented by a priest whose name was Augustus Russell Pope. So he invented a first alarm system. Now this alarm system was very simple. So he connected electrical circuit to the doors and windows which were closed at night and people were sleeping. And this electrical circuit was operating in a normally open condition. And when somebody tried to open, these doors went into a normally closed, the system went into a normally closed position, which then a current was passing through the system. And this current magnetized the magnet, and the vibration of the magnet got transferred to a hammer, which then rang a bell. So this was the first alarm system which was introduced to the world, and the first security system. And the next development happened. There were small developments in between. I'm not going through that. In 1949, when Nazi Germans were firing their V2 rockets during the Second World War, and they used CCTV system for monitoring these rockets, as you can see in the picture. This system was developed by Siemens. And the most important discovery came, as you can see, through a lady called Mary Van Braun. And she is considered to be the first person to assemble the security system as a security solution. So Mary was a nurse by profession, and she was staying in the city of New York, in a very troublesome area where there were a lot of security breaches happening, security threats happening. And Mary, after a long day in hospital, wanted to relax and didn't want so much of disturbances happening. The pattern of these type of disturbances was that most of the time somebody would knock the door, and people will open it unknowingly and ran into trouble. So Mary devices asked her husband, who was also an electrician, to devise a simple system. And the system was like this, that she put 3 holes in a door. One was a small hole through which she could see a small child if a child was standing outside, a hole in the middle level for a medium height person, and a hole a little bit up for a person who was very tall. And she put a camera behind the door so that this camera could move from one hole to another. And the camera's output was taken to a local TV which she had at the home through a existing radio system. And she could also communicate with the person who was standing outside through a microphone. And she could get a response from them to ascertain whether the person is known to her. Again, in case a person was a troublemaker, she could press a button, and through the telephone lines that could send a signal to the local security authorities. So this was the first electrical security system in the solution sense, combining 2-3 systems together. And this still remains the basis for home security. When you talk about home security, you talk about a camera, you talk about an intruder system, you talk about a communication channel, all these put together. So this is a little bit of brief regarding what is happening in security, how the concept evolved. With this, what happened is a lot of requirements came, a lot of people started investing in security systems. The business started growing. Many big players entered the security systems. And based on the requirements, security system is classified into 5 major categories, as you can see in this slide. The first one is access control system. The second is the CCTV surveillance. Then the intruder alarm system, fire alarm system, and the perimeter protection. Perimeter protection relatively new, but I've included because it has become a major category in terms of market size and business. So we'll be going to one by one in all these systems and try to understand as much as possible in the limited time given to us. So I'm starting off with access control system. As you can see, the basic components of an access control system is the access control reader. Reader reads the details which is presented to the reader in the form of your identity. Reader then gives the information to the controller, and the controller decides to open or keep the door closed, allow an entry or not to allow an entry based on the inputs received from the reader and how it identifies. So in access control system, there are 2 parts. First part is that you have to register yourself into the system. You register your card or your fingerprint or whatever ways you are trying to enter into the premises. And an image or details of your card is taken and put into the database of the system. And once we go there for the second time, the details given are compared with the details already available in the database, and accordingly a choice is made. And there is also something called as access control software, which will be residing in a client. This access control software does all the configurations, like when a controller is handling different areas, different doors, door number 1, door number 2, reader number 1, reader number 2, all these configurations. Plus, the software also integrates the access control system to other systems like risk management or a fire alarm system or a CCTV system in case of an emergency. So overall, the configuration and the integration part is done by the software. On the software, you also get reports of who has entered at what time. And you can get daily reports, and many types of customized reports can be made using the access control software. So this is the base of an access control system. So depending upon the type of identity you're showing at the reader end, access control systems are classified into 3 main categories: card-based, the biometric-based, and the mobile-based. The first one is a card-based access control system, which is very popular in India. So you can see that almost everywhere, everybody carries a card to their office. So the card-based system has 3 steps involved, from a basic system, which is called as a Huygens wire card. This was developed by a German scientist, John Huygens. And you can see as in that top picture, small bits of wire which are embedded into a card. These wires are called Huygens wires. These Huygens wires were an invention of John Huygens. These wires are a ferromagnetic alloy of iron, cobalt, and vanadium. And with this was subject to a special treatment. These wires hardened, and it had a hard outer core and a soft inner core. And when this was given to a magnetic field, there was a sudden change in polarity. While the magnetic field was getting saturated, wire was getting saturated, there was a sudden reversal of polarities, which created an alternate field and alternate voltage, which could be read by the access control reader, and the details were transmitted to the controller. Now, the voltage pulse has to be converted into a readable form, which the controller understands. So that process was handled by the reader, and the conversion of this voltage format into a readable binary format was done inside the controller. Now, each of the small filaments which you see in this card are cables of carrying a memory of 1 bit. So you can see almost about 26 bits embedded into this card, which is called a 26-bit card. And this 26-bit card, when you're using, we have to allocate the space in such a way, the bit space in such a way that you should be able to accommodate the unique features of the card, the unique number of the card, as well as give some space to identify the facility, which means about 8 bits go to the facility code, and the rest is taking care of the numbers. 2 are there for correction purpose. Totally it is 26. The facility code means identifying the area where you are going to put this card, like it may be a country, state, or a particular location inside your premises. So this Huygens card became popular and considered as the first type of cards used in security systems, but had a limitation in the sense that this was coming from the manufacturer straight away to you, so you have to rely on the numbers given to you. And when many manufacturers started manufacturing this system, there was a duplication of the numbers, which led to a lot of confusion in the security market. So, but then this card was could not be copied, and we are talking about wires embedded. The data was very safe, but it had a limitation in terms of the size of the data. Also, people understood that the maximum number of filaments which can be embedded in the card was 37, which also proved to be a major limitation. And there was a thought process being done to how to improve the memory of these cards, how to improve new features. Because by then, everybody wanted to write their own numbers in the card so that it cannot be duplicated anywhere. I want in my installation to write my own facility code. I want to enter certain details. So the second type of cards came into being, which is called as proximity cards. Proximity means the card is shown to the reader. You don't have to touch the reader. In close proximity of the reader. And the technology used was RFID technology. The frequency used was 125 kilohertz. This card had, as you can see from the third diagram, a small chip on the top, the black color chip, in which the data of the card, the unique data of the card was embedded. And you can also see a wire coil, which is a LC circuit. And again, the reader got modified into an RFID reader. Now, when this card was shown to the reader, this circuit got tuned to the frequency of the reader. Both were working in the design for the same frequency of 125 kilohertz. So this tuning generated a small power, which could power the chip, and chip could start giving the details. So this was a technology used. Again, this was found to be inadequate because a lot of people started copying these type of cards. Data was getting copied. Fake cards were being produced. Access became a problem. So technology again improved, and we started using the latest type of cards, what we use today as called as smart cards. Smart cards are called smart cards in the sense that they carry more data. And when they're carrying more data, the data is in an encrypted form. The data cannot be stolen. And again, because of the large size of data, the memory can be distributed in various compartments. And each of these compartments, you can read and write whatever you want. And using all these different compartments, this card can be used for different applications. Like you can use this in your canteen, you can use this in your as a parking station, you can use for your vendor machine. You can so many applications are there. So since this one card could be used for so many applications, this was generally called as a smart card. So this card operates on the radio frequency technology of 13.56. And this is the card which is being used today. So when we talk about a 26-bit memory, which is, if you convert the byte terms, divided by 8 is almost 4 bytes. Today we have reached the stage when we have cards which are having 1 kilobytes and almost up to 8 kilobytes per card. So memory has increased substantially. So we could save a lot of data. We could read and write whatever we want to. We could customize it. Each of these segments were again protected, encrypted properly. So this is where the card-based access control system stands today. So all said and done, the card-based access control system had a major disadvantage. Cards could be copied. I can give my card to somebody else who can enter the premises. I am not verified. My card is verified. Again, once you lose a card, there's a major problem of security. You have to alert so many people, and you have to make them aware that card is lost. So the next technology emerged, which was a little more user-friendly in the sense that this system emerged from the physical features of a human being. So this is called as a biometric access control system. As you can see in the definition, this system measures and statistically analyzes biological data using scanners. So the different types here are fingerprint, face recognition system, palm vein, iris scan. There are other 2-3 smaller types which I'm not going into it. I'm talking about the major types. The first and the most used system in biometrics is a fingerprint-based system. As you can see in the diagram which is shown, a finger is unique. Finger has got 2 layers. The outer layer and then the inner layer. Outer layer has got all these lines, specific lines, which is unique to the finger of a person. There is also an inner layer where you have the tissues and the sweat glands and other things. So a finger is unique, and it is one of the cheapest form of biometrics. Very easy to use. You just have to show your finger, and it is done. It cannot be easily duplicated because finger is unique for every human being. And this outer layer is called the epidermal layer, and the layer below is called as the dermal layer. So scanners started developing, and the first scanner used was an optic scanner. Optic scanner, as you know, has got a light source and a photodiode, which is a sensor. which receives light. The light illuminates the finger and takes a picture, which is given to the system and is compared with an image which is already taken and is stored in the database. But the photo scanner had a lot of limitations because simply it was taking an image. So people try to duplicate in such a way that they could bring a photo of the finger and try to show it to the reader. Reader used to accept that. Again, prosthetics models, artificial models of the finger could be used in certain scenarios. Again, when the finger got contaminated due to dirt or dust or oil, or sometimes due to some disease, this ability was under question. So the second type of reader evolved, which is a capacitor-based reader. Capacitor, as you know, the capacitor technology, and there is an array of capacitors which is embedded inside the reader. And when you put your finger middle layer acts as a dielectric, and the layer below that, the dermal layer, will act as a second plate. So the capacitor is basically two plates and a dielectric between. So the change in capacitance was happening because of you pressing your finger was detected, and this change was noticed, and the change was unique to a particular finger, and the change was read by a backend sensor and compared with the system. Nowadays, we have moved into ultrasonic scanners, which you can see in mobiles. Ultrasonic scanners again use ultrasonic technologies, and the technology is improving day by day. And finger scan system, as I told you, is the cheapest, easy to use, and occupies about 50% of the biometrics market. Coming to the next, the most important, face recognition system. Face recognition is an important type of biometrics in the sense that human beings identify each other by looking at the face. So the technology uses the unique features of your face through which a comparison is made with an existing data and the face is identified. But when we talk about a human being identifying a face and a computer identifying a face, it's totally different, because computer doesn't have the intelligence to identify face as fast in the same way as we are able to identify. The process is a little more complex. So in a face recognition system, there are four processes. First is as the face is detected. Then there are certain nodal points on the face which are taken out, basically your shape of your nose, shape of your eyes, cheekbones, then jawline. All these nodal points are taken out. Then these nodal points are geometrically calculated and made into a mathematical formula, vector formula, a vector version of your face. And this is called as the face print, similar to the fingerprint. So a unique face is detected, features are extracted, and it is compared with the data or the face which is available in the database. So this system again had its drawback because you have to show your face in front of the camera. Although this is very easy from a user point of view, you just have to come and stand in front of the camera. But the full facial view has to come. The camera should be having a good resolution. Again, the lighting condition should be ideal so that the picture comes properly into the system. If these things are not taken off, the face recognition system is sometimes become erratic, and there are chances of a genuine person not able to enter inside a premises or a false person entering into a premises. So we were talking about the limitations, but then the technology developed in such a way that we are asked today now to identify a person from a crowd, as you can see from the picture. In a crowd means you must be walking in a road where there are no ideal conditions. The camera may not be the right one, the lighting conditions may not be the right one. And you may not get a frontal view of your face, you may get a side view or a partial view. So that is when the concept of artificial intelligence has emerged as a basic support factor. Artificial intelligence using this specific algorithms called the neural networks or the conventional neural algorithms use. They capture this small portion of the face and and study detail in such a way that there are certain features which are extracted from that small portion and compared with the existing data, and there is a identification happening. So face recognition system is coming out of age, coming out of its limitations. And today we are seeing systems in countries like China, where all the people are being tracked, all the people are being identified using the system. But then the initial system also had some issues, like if your face expression changes or suddenly you tilt your head, the image becomes a problem. Sometimes it causes a rejection. So all these factors, the behavioral factors, has been taken care of by the artificial intelligence systems, and the face recognition system now stands in a much comfortable state. As you know, India government is going to implement this as part of the Aadhaar identification scheme now. So that's where we stand on face recognition system. Going to the next is the palm vein based system. The reason why I've included this because this and the previous one, face recognition system, and the next one, which I'm going to show, are not touch-based systems. So in this COVID age, when we are trying to avoid touching anything, the touch-based system always becomes an issue. So finger scan is a little dangerous today. So we should, the whole world is encouraging systems where we not touch anything. The palm vein is one of the most accurate systems in the sense that this is taking an image of the veins inside your palm. So identification data is not exposed at any point of time. Like the issues which are happening in face recognition system, your face is available everywhere, and that becomes a privacy issue. A lot of countries are, shouting against that. A lot of people are shouting against that. So the palm vein system is very simple. You have to show your palm to a reader. It is an infrared reader, and it takes an image of your palm. And since it is an image of your vein, it's unique. It doesn't change over a period of time, like the face, which can change over a period of time. The features can change due to aging. Here, there are no such issues. The palm vein remains the same right from your childhood to our end. So the system is unique, and also there is a advantage of a large surface being captured because you're putting you're showing your palm against your finger. So more data points are generated, and more data points generating means the more accurate your identification becomes. Compared to about 40,000 points in finger recognition, we are talking about 5 million points in palm vein based system. Again, there is a liveness detection because this captures the actual blood flow along with the palm vein, so it is difficult to cheat the scanner. But the disadvantage, because we need a special system to read this, so it is comparatively expensive. And in some cases during cold weather, when the temperature changes, the blood flow restricts, and sometimes it gives false alarm. But overall, the accuracy is almost close to 100. The false rate is 0.0001. So this is considered as one of the most accurate systems. This system is widely used in Japan for payment purpose. In Korea, you can see the system in all the domestic airports. Slowly coming up in other areas. I'm sure India will shortly start introducing this system. Cost has to come down a little bit. But then this is one of the most accurate system and the most user-friendly system. And that's where the system stands. A similar system called the iris recognition system, as you can see from the slide I've given you. The first thing which comes in your mind when we talk about iris recognition system is the Aadhaar enrollment process in which we got exposed to the system. So when the iris recognition system talks about a market about 1.5 billion users, we are talking about 1.3 billion users from India alone. So the system is capturing an image of the iris. Again, iris doesn't change over a lifetime, it remains stable. Iris is a small, what you can say, a muscle which replaces a pupil. And it's flat shape, fine structure, well protected by the cornea. Again, a movement of iris is always there. There's a liveness detection. It shows that you are alive when the image was captured. Image can be captured from a distance. But again, beyond 2 meters, it becomes difficult. But the cons is that you need to have a specialized camera. You cannot take an image of an iris because iris image is very much intricate, and you need to have fine details of the iris so that it can be compared with an existing database. So the fine details means you need to have a camera which can have an IR based backend support. Visible light spoils the iris image, so it should be taken with minimum visible light. Again, you will have to stand in front of the camera for some time, and you have to focus on this. So this and the palm vein recognition system, which I mentioned earlier, are all accurate system, but works only on ideal conditions. That's the reason face recognition system has overtaken all this. This is again because of this camera. We need a 5 megapixel camera, which is very expensive. This expenses contribute to the high cost of the system, and this high cost is limiting the system from spreading into the basic level markets of security system and still remaining in the higher end with a limited market share. So this brings to an end to the biometric systems. So a quick comparison of the biometric system, you know that the finger scan, 100% unique iris, and again, you talk about palm vein is 100% unique because the factor utilizes 100% unique. Face recognition system is 80% unique because sometimes problems can come if the image is not captured, although the face is unique, which is again corrected to a great extent in 3D face recognition system, when a 3D image of the face is taken using 3 cameras or using a laser beam. Very fast when it comes to finger scan and 2D, and a little bit slower when it comes to iris and other systems. Accuracy is 100% in iris and palm vein, little bit lower in other systems. Cost, finger scan, face 2D is very low, the others are very high. So the latest technology, since we are using mobile today, the latest access control system technologies are all mobile based. It will not come up in a big way in India. It's in a very experimental stage. So 2 technologies are being used. One is the near frequency technology, which is your mobile has to be NFC technology based mobile, and your reader again has to be a near frequency technology based reader. So when your mobile is shown to the reader, the details which are there in the mobile through a software are transferred and your access is done. Again, Bluetooth technology, Bluetooth low energy. This is a variation of Bluetooth, not the normal Bluetooth, but comes along with the Bluetooth, is available in all smartphones, and these are also used for access control systems. But these systems, as like your phones, are exposed to cybersecurity threats. Your data is not safe, although in some cases, some processors of some mobiles ensure that the data is taken to a very safe location inside. And the Bluetooth system sometimes asks you to register every time for every application. Suppose I am going to a door, then I have to register again, then I have to go into a parking lot, then I have to register again. So this re-registration process becomes cumbersome and a little stressful. Even then, this is a new technology which is going to be there, which is going to be the future of access control system that's coming up in a big way. From the access control, we move to the CCTV and surveillance. CCTV is the most popular system. As you all know, you don't see a place nowadays without a camera. You can see it in your buildings where you're staying. You can see in your offices, everywhere cameras are there. China has so much of cameras that they are saying that in 2025, there will be a camera for every person in China, and in US for every 5 person. India has also got about 50 lakhs cameras, almost catching up with these people. And typical CCTV system consists of the cameras. You can see the different types of cameras, the dome camera, then this is called as a bullet camera, this is called as the box camera, and this is the parent tilt. Dome camera used for indoor application, bullet camera used for outdoor, pan and tilt, you know that pan, horizontal movement, tilt, vertical movement, the zoom lens. So these cameras are called PTZ or pan and tilt cameras. Nowadays, the cameras are all digital cameras, so they are connected to a recording device called the NVR, network video recorder. From the network video recorder, it goes to a video management software. The video management software does the configuration like what we saw in access control system, identifying camera 1, 2, 3, 4, and again, what type of cameras are used, how to store the data. For example, somebody wants to store the data for 30 days, what frame rate it has to be stored. And also, if you want to integrate a CCTV system with access control and fire alarm system for an emergency situation, these things are all done by the video management software. So that is an important area which we have to look at, and it's the heart of the system. In small systems, the video management software is embedded to the network video recorder. When we talk about 16-channel NVR or 8-channel NVR, means 16 cameras or 32 cameras. This video management software becomes part of the NVR, and the NVR works as a client and can be connected to a monitor directly. Otherwise, in big systems, the video management software resides in the central command center from which all these properties are being done. So the development CCTV, the first thing which has happened was first conversion of analog to digital technology. Analog means a wired system where the cameras were hardwired to the recording device, which was then called as the digital video recorder. So analog system from analog signal from the camera was converted to digital signal in the digital video recorders. Nowadays, you have got cameras which are digital or IP-based cameras. And these cameras have become intelligent in the sense that you can see a type of camera in the picture which is used for home applications, which can even do a sort of a motion detection, or you can view this camera through your mobile through an application. It can alert a fire station if there's a fire, and so many other features which you can see. The real-time motion tracking, artificial intelligence-based motion detection. So these cameras are web-based cameras, which are called smart cameras, which are used for home security applications. Again, when we look at the big cameras we are using for security, these cameras have got edge-based analytics, edge-based intelligence built into it, through which you can perform a lot of tasks. These cameras have also got local storage using SD micro drive devices. So a lot of memory can be saved in the camera. You don't have to depend upon totally on your DVR or NVR capacity. And the next point is better video compression technologies. Now we are talking about digital cameras, means we are talking about lot of picture files being transferred through the network. So this has to be compressed in such a way that the bandwidth is properly utilized, and this transmission of this video image should not choke the bandwidth. So compression technologies have been developed. S.264, you must have heard of it. MPEG-4. These are the compression technologies where the video is compressed in the camera itself and before transmitting to the recording device. And the main point is the main development has happened is video analytics. Video analytics means a software or the intelligence built to perform certain task based on a rule base or on a general base. When you talk about a rule base, you're talking about rule-based algorithms or rules written to perform specific task. Like people counting, you must have seen these cameras in malls where footfalls are being measured so that they come to know about how many people come every day. Generally, they come to know about how many people come in a month, or how many men or women out of that, what is the choice preference. Accordingly, they can design a business model to suit these type of observations. Another area which is the automatic number plate recognition. Means the number plate of a speeding car has to be recorded at a toll station, for example. So we use cameras which have got frame rates, much higher frame rates, and placed in such a way, in such an angle. Most of them will be having night vision capability also. So number plates are recorded and compared with the number plates given in the system. And motion base, which is a common feature today in all the cameras, instead of recording a particular area for a long time and getting so much of files, so much of data which are unwanted, you detect a motion and then only you record. That means if the motion doesn't happen in a room where a camera is placed, the recording doesn't happen. Then object detection, of course, an object you can see in that square which is given as an object. If an object is there for a long time and nobody is taking care of it, it can be a source of trouble. So the camera features are, the video analytic features are programmed in such a way that maybe for about 5 minutes or 10 minutes, whatever time we are specifying, after that, the system gives an alarm that there's an identified object and you can take action on that. And dynamic masking, in the sense that if you're recording in a particular room and there are certain areas which you really don't want to show for privacy reasons, you can mask that area, you can cover that area, you can scramble that area so that the data is recording only what is required. The recorder is recording only what is required. So this much about video systems. From video system, we are moving on to the next system, which is called as intruder alarms. Intruder alarm, as the name says, that if there is an intruder in your area trying to break in, there is an alarm. I recall, I take you back to the first system developed by, alarm system developed by Mr. Pope. Augustus Pope was an intruder alarm system. More or less the same system is still remaining. So when we talk about an alarm system, we will always have an alarm panel, which is there. This is alarm panel. And then we'll have different type of sensors to give alarm from different areas. And there will be an external software required, which gives a sound alarm in case it is required, or else it will be connected through GSM or GPS so that you can alert the owner in case of an alarm in his mobile, or a GPS system. The security agencies can track the exact location where the alarm is there. And there is a keypad you can see in this alarm control panel. The keypad is used for programming the devices into the system, configuring the devices, various sensors into the system, giving them names, locations, all these details are there. Plus, the keypad is also used to enter a security code so that you can lock the system, you can lock your residence or whatever area you're there, and you can, and the specific code is also used to unlock. So different types of sensors are used. The main type of sensor used is the passive infrared motion detectors, which are installed at areas like, for example, in front of a door where we are expecting an intruder. And passive infrared detectors will have a transmitter and a receiver. There will be continuous. Once it is activated at night, or a shopkeeper who has closed his shop and gone to sleep, gone to his residence, when this is activated, the infrared beam, the invisible infrared beam starts transmitting between the transmitter and receiver. And somebody enters, he's trying to break into the beam. And the difference in temperature, because when we talk about passive infrared system, we are talking about temperature. And when a temperature difference is observed when a human being enters with a certain body temperature, that is sensed and detection is happening. Again, vibration detectors are used when we are talking about somebody trying to break a wall or somebody trying to break a door, and the frequency of the sound is again compared with the settings given in the vibration sensor, and accordingly alarm is given. Glass break detectors are used in windows. When somebody tries to break open the glass, the sound which is produced, it's more than the threshold sound to which the detector is set, and that gives an alarm. Again, magnetic contact sensors are placed on doors mostly shutters, where the wiring part is kept on the base and the magnet will be on top of the door, and the shutter is pulled down. The magnet comes in contact with it, and it remains in a closed system, and somebody tries to break it or lift the shutter, then the circuit becomes open and gives an alarm. So dual technology sensors like IR and microwave are used in most of the cases. Nowadays, these type of sensors come in dual form, basically because one technology is not enough to sense totally what is happening. IR sensors can be easily pooled, as you can see in the next slide. And so that there has to be a backup sensor which could also identify what is happening. So when two technologies are used, like an IR and a microwave, and both of them senses then intruder only, the system gives an alarm. So intruder alarm system, latest developments, it's part of a web-based network, grid network, you can say. And detectors come with anti-cloak and anti-masking features. As one of the ways people try to fool the passive infrared detectors is that they wear a cloak or a big coat so that the radiation emitted, see, basically there is a radiation emitted from the human body. The radiation emitted is minimized and weak so that they can override the sensor. The sensor comes with an anti-clock feature, which means that it has to be a dual sensor, and one sensor doesn't recognize based on temperature. Maybe a microwave sensor and a PR together. Microwave can sense the person entering and give an alarm. Anti-masking features basically means people try to mask the sensor. They'll try to put some paper, or they'll put some spray something so that the sensor doesn't detect. Here, the advanced PR sensors have come into the markets, where this the emission of PIR is given back to the sensor instead of going forward towards the receiver. And once it goes back to the sensor, that difference is again sensed by another diode, and this PIR and this infrared detection, infrared rays are taken outside when it goes to the surroundings and reflects back from the walls, and the reflection is sensed by a sensor which is on the back side of this PIR. And using that reflection density, we identify that there has been a masking effort. As I told you earlier, web-based intruder alarm system, all part of a IP control system. Systems with distributed control basically means that there are multiple systems operating together in a big area. One system will have control. It can also monitor the other systems. Remote monitoring, as I told you earlier, with GSM, GRPS, or IP module. Then wireless systems are now greatly in demand as part of the home security, like the wireless camera I told you. Wireless intruder alarm detectors are also used for home security. And system redundancy. System redundancy means if one panel fails, there is a support from the other panel which acts as a backup and gives information of the status of this panel, what is happening. And these are the major developments which has happened in intruder alarm system. So more or less, this is a system which is alarm-based system, which has got an alarm panel and sensors. Coming to the fire alarm system, which is the most important in terms of security, because fire doesn't give you time to do anything. Fire spreads all of a sudden and destroys everything. So you need to have active detection device, very accurate detection devices, so that fire is identified well in advance, fire is treated well in advance. Fire authorities are informed well in advance so that the fire is put down without causing major damage. Again, this being an alarm system, we'll always have a control panel, which is called the fire alarm panel in this case, and the fire sensing detectors, as you can see from the diagram. And pull station. Pull stations basically are manual pull stations, which you can see near the door of your building, where you can pull the handle in case nothing works. It's a manual way of sending a signal that there is a fire, or you can break a detector, glass break detector, using a hammer, which is given along with that. And the fire alarm panel senses that as a fire signal and gives an alarm. So here the role of the fire alarm panel is very important, because the fire alarm panel, apart from sensing the fire from the detectors, also has a job to control the auxiliary systems like lift. The lift is going up or down, it has to bring it down to a certain level fast. It also has to control the air ducts so that the fire doesn't spread through that. It also has to alarm the authorities for that. And if it is connected to a sounder system, as you can see in the diagram, it has to give a sound alert, a voice alert, sometimes integrating the public address system. It has to give an alert to a wider audience throughout the building. So fire alarm system is a core. It has to act fast. Again, it also has to activate the sprinkler system. In some cases, the fire is major, then the sprinkler system has to be activated so that water starts falling down. And again, gas suppression system, which are used for fire prevention and fire suppression. All these are being activities are being controlled and performed by this fire alarm panel. The type of detectors, smoke detectors. Smoke is the major factor which identifies a fire in the fire detection system. Two types of smoke detectors: ionization and smoke photoelectric. Photoelectric basic technology, like you have got a light source and there is a photodiode. Normal situation, the light is not falling on the diode, but when smoke enters the chamber of these detectors, the light is dissipated and some part of the light falls on the photodiode, giving an alarm. Ionization smoke detectors means we are talking about ionizing the air around the detector using a radioactive isotope. And when the air around is ionized and there are electrodes inside the detector which gets charged, and there is a current passing through the detectors, and the smoke enters the detectors, this charging dissipates, or ionization becomes less, and the current becomes less, and the difference in current is given as an alarm. Heat detectors mainly used in pantries and kitchens where you cannot have a smoke detectors because smoke is always going. So one of the ways of detecting is identifying the heat. There will be a heat element inside the detectors. Two types again. One detects the actual temperature inside the heat element in the detector. Other talks about the rate of increase in heat, incremental increase in heat. If there is an increment of 6 to 7% and it's happening all of a sudden, there is a detection. Gas leakage detectors to detect gases. Air aspirating detectors, the last one which you can see in this. It's used mainly for clean areas, like when you talk about a data center where fire originates in a very specific area and starts coming up. So you need to identify fire at a very basic stage. You can't expect the smoke to come up. So the air aspirating detectors keeps on drawing the air using a fan and keeps on sampling the air. Even the minute particles of smoke which is there in the air can be detected using these detectors. Of course, things like dust and other things are filtered out. So this is widely used in clean areas, as I told you, in control rooms and data centers. Then combination detectors. Again, here we have a combination detector, like can be a smoke detector and a heat detector in combination, so that one of them will work fast and gives you a detection. And the beam detector. Beam detector is basically an IR-based detector or a photoelectric detector, but it's installed at a height. When your height of the ceiling exceeds 7 meters, you go for this beam detector. And when the beam detector has got a transmitter and a receiver, and when the signal is cut between the transmitter and the receiver, when the fire comes up, it gives a detection and it gives an alarm. So this more or less covers the fire alarm systems. The developments which has happened in fire alarm system initially was a conventional fire alarm system. Conventional means you had detectors and a fire alarm panel, which is divided by number of zones. So when a fire happens, you only get an indication of the zone in which the fire has happened. Zone will have multiple detectors, which is very difficult to pinpoint the fire location. So it takes time for the firefighters to reach that area, which might become fatal in some cases. So addressable fire alarm systems came into being where each detector has got an address, and each address is mapped to the fire alarm panel so that the fire alarm panel can pinpoint the location of the fire and people can reach there. As per the NFPA specification, it should be within 60 meters of your reach. Once you open a door, within 60 meters is the maximum space allowed for the person to reach before the fire is acted upon. IoT-enabled fire alarm systems, smart smoke detectors are also installed in buildings nowadays, which can do a lot of functions like the smart cameras we talked about, that smart intruder alarm detectors. Wireless fire alarm system used in buildings. And video-based fire alarm system, when we talk about a video capturing the fire alarm along with the detection, so that we get a clear picture about what is happening from a remote distance from the control room, and we can act upon fast. So this more or less brings towards the end of these type of system, and the last one being the perimeter detection. Perimeter detection means you are detecting the security threat in a perimeter of a large area. Mostly this type of this is a developed form of an intrusion alarm or intruder alarm system. Only difference is that these sensors are large in numbers and the area to be captured are more. So different technologies are used here. You can use a fiber optic which can run along with the fence, and if something happens, somebody is trying to climb the fence and the fiber optic cable is cut or pressurized, the light transmission gets affected at the other end, and the sensor or the panel detects low intensity of light, which can be a reason for the intruder trying to get in. Then taut wire fence system. Taut wires are used along with the fence, almost like a second fence on which you can put different types of sensors. Passive infrared, as I've already discussed, the same technology. Active, sometimes thermal cameras are used. Thermal cameras means it's a type of camera where camera identifies the heat. And from the heat source, it identifies there is a person or some movement involved, and accordingly captures an image. So here we are not talking about an ordinary camera, visual camera. We are talking about an IR camera. The camera has got an IR lens specifically to take care of the extreme temperature conditions or the extreme conditions under which it is going to operate. Mainly these cameras are used for fire detection. Firefighters use this camera in a big way. And when it is used in the perimeter detection system, these cameras can go to a greater length, and at night it can detect small movements because it detects the temperature of the person who is coming towards it. Then microphonic system, which means the use of microphones installed at various places so that the information can be conveyed. And these are the basic technologies used. Applications means you're talking about high security environments for airports, international borders, big industrial establishments. So basically, this system takes care of your intrusion into a large area by keeping sensors located at different points of the fence. And these sensors emits a certain radiation, and when somebody tries to break in or cut through it, then it is sensed. So we almost come to the end of this part, which is the different types of security systems. And we'll go to the next, which is called the market size. As you can see from the table, the security market is almost a $200 billion market, dominated by CCTV, fire, and access. Access basically because of the biometric systems. CCTV basically because of the different types of cameras in the home segment, the smart cameras, which are the home segment is growing at a very fast rate. Fire alarm system maintains about 40 to $45 billion every year because it's an essential part. So it has to be a mandatory, it's a mandatory requirement, but keeps on growing. Perimeter is coming up in a big way. Intruder, as it is a 3.5 billion market, but when it is combined with the home security, that also becomes a big figure. Growth rate, access is growing at 11.5% even now because of the biometric systems being used. CCTV 10.5%, but in India, CCTV is going at almost 16 to 17%. India has got, as I told you, about 50 lakh cameras. Intruder alarm system almost 6%. Fire is 8.5%, more or less steady over the years. Perimeter is fast growing from a percentage of about 2 years back. Now we have reached a level of 7.7%, which is a big growth in perimeter systems. So this gives an overall idea about the global security market size and how it is distributed across various systems. Coming to the main players, you can see a lot of big names: Honeywell, Siemens, Bosch, Johnson Controls. These are the big players who have got almost all types of systems with them. They can also integrate. They are known as system integrators who does the integration job of all these systems, and they maintain it. Hikvision, a big name, a Chinese company who's the #1 in CCTV cameras. Fujitsu, known for his palm vein readers, fingerprint readers, and also iris recognition. ASA Abloy AB has got finger scan as well as the cards. You must have seen the name HID in all these cards. HID Corporation has been taken over by ASA Abloy, a Swedish company. United Technologies Corporation, another big name. NEC makes face recognition system, and they also are into iris recognition system. NEC Corporation, Japan. So these are the big names of the big players. All of them has got their presence in India. Hikvision even has a factory in India where they're making cameras close to Mumbai. Others have got a big presence. They're doing a lot of projects, security projects in India. And next is the privacy concern. Privacy means the privacy concerns which is caused by security. So I'll show you some scenarios which has happened in the world. Average citizen in the city of London is caught on a CCTV camera 300 times a day, as per the reports available. A museum security camera was used to spy on German Chancellor Angela Merkel. The museum was close to a house, and it was accidentally discovered by a journalist who was trying to make a report on how the museum is guarded at night. He actually bumped upon a guy watching Angela's house and spying on it. Mass surveillance of citizens by China. TikTok agreed to do a 92 million settlement US lawsuit for use of face recognition technology to collect highly sensitive data. City of San Francisco voted to ban face recognition system. So these are some of the major scenarios. Coming to what a security practitioner can do is that he should be aware of the legal and security concerns of security systems. He should know the rules and laws of the game. You should clearly define the purpose of data usage along with the restrictions. You should perform a data lifecycle analysis. Data lifecycle analysis means you should know how this data, where the data is originating, where the data is entering and ending, who are the users, how they are using it, what are the levels of security and access levels given to these users. So a life cycle starting from the end of a particular data being handled from the beginning to the end is what is called the life cycle analysis of data. Then security auditing means periodic audits are concerned to ensure that there are no violations in security rules. There are no changes in terms of access levels happening. Access level assigned to a person is given. There are no changes happening. And we also see that the system is followed in a better way, and what all changes we can do it in the system to make it more efficient. These are all things which we identify by security auditing. And again, as I told you, use of technology to protect the privacy of the individual. Technology means like masking of areas where which we don't want to do it. So from a government point of view, there has been no rules and regulations anywhere in the world which secures the privacy of individuals. Privacy is still a big issue for us. New York, in the United States, different states have banned face recognition system, but overall there is no policy. In India, what we have done is we are talking about legislation which has come up recently, through which the India government is trying to compensate for the privacy compromise which is being affected by the citizens. And this is still in a very nascent stage. A joint parliamentary committee is looking into it. This bill is called the Personal Data Protection Bill. This was introduced in 2019. Previously, India had only an Information Technology or IT Act, which was made in 2000. It is still being used. Now, this new bill, if it becomes a law, will take care of some of the privacy issues of individuals. And we can, through a law, we can fight these issues in the court. But still, as I told you, it's being discussed. And nothing has reached a level where we can say that there's a rule in place. So there is a trade-off between privacy and security, and we will have to decide what is more important, whether privacy is important, security is important, and that's a thin line separating the two. And we have to identify and acquire that balance so that we give minimum details to the system, and we safeguard our privacy in a better way so that the critical details are not leaked out in any way. That's the best we can do when it comes to privacy. Coming to the last slide, which is the future, the road ahead. The security systems is going to remain as an IP-centric system. More and more IP devices will be there. There will be more system with open protocol. Open protocol means it will not be a device-based or a particular manufacturer-based. We will have more devices in the system from different manufacturers. The system will be working in a common platform which is open to all. Integrated security systems that we can integrate access control, CCTV, fire alarm all together and give a combined security to the establishment we are protecting. Artificial intelligence based development, which I told you, has happened in many fields and happening in a big way. Video surveillance as a service, BSSAAS. It's one of the business model which is being identified basically because the data is now going to the cloud, and cloud is more way of securing a data. When cloud becomes a service, video surveillance becomes a service. Then with this, when we are becoming more IP-centric, the security risks which are associated with IT are also a common security risk. A hacker can get into the system very easily and see the cameras and see what is happening. So the typical security protocols which we are maintaining as part of our IT has to be followed here also. And the major threat is going to happen from IoT devices. Basically, the IoT devices which are there in the system, more and more IoT devices are being added to the system, and all are going to be in a common platform. IoT devices, lighting devices, HVAC devices, they are all IoT devices. All of them have become a threat because we don't know the level of security these devices are maintaining. Somebody can enter through these devices and the software used by these devices and create a major threat. So these are the major areas of the road ahead which we are talking about. So with this, I come to the last part of my security systems. I like to quote Phil Crane, an American Republican leader, who has given a very good statement. It says that I certainly respect privacy and privacy rights, but on the other hand, the first function of a government is to guarantee the security of all the people. So security is important. Security overrides all other small issues which are related to that. And with that message that take security seriously, I come to the end of this this presentation. Thanks to all for listening to me. Thank you.
Hello.
Yeah.
Uh, Thank you so much, sir. That was truly a great session. So now we have some questions from the participants in the chat section. Can we move on to the question and answering session?
Of course, I'm ready.
Yeah, sure, sir. So, sir, the first question is, can't people lift fingerprint from objects and use it to hack in?
Not possible in the present scenario when we talk about systems where you actually have to use your finger to identify the system. Earlier, it was possible to some extent. Again,
okay, sir.
The whole thing is
the next question is, what will happen with palm injuries?
Palm injuries, if it happens in the peripheral of the palm, it doesn't work. But if your palm has got a major injury, it cuts through your nerves and cuts through your interior parts of the palm, there is a problem with this system. But that's a very rare case.
Okay, sir. So that is the end of the questions from the chat box. Are there any more questions from the participants?
Pratap Kumar, thank you. It was a great session. I loved it. I would like to know the context of Corona and am I audible or no?
Can you speak a little louder? I'm not able to hear you properly.
In the context of Corona,
okay.
In the surveillance system in airports or places like that,
okay,
and people are coming in crowd, whether we do we have enough sensitive thermal infrared cameras which can identify the variation in temperature, or it is too small to fight?
No,
variation of the
we have this system in place now. A lot of Chinese vendors have come up with these type of systems which can detect this temperature range. They can also detect your face even if you are wearing a mask. Those systems have come up and it's already being implemented in various airports and other places in India. So system is there.
People can be identified and isolated. People with fever can be separated out, right?
Of course. In our company, we are going to implement that once we open and we go to office after the COVID.
Okay, great. Thank you.
Thank you, sir. Any more questions from the participants? Okay, so I think that is the end of the question and answer session. Shall we move on to the vote? We shall move on to the vote of thanks.
There is a question in the chat.
Yeah. Sure. Okay, 1 minute. Okay, so the next question is, in the road ahead, can you see a self-managed system?
Self-managed system?
Yes, a self-managed system. In the road ahead, can you see a self-managed system?
Security is self-managed system today. As I told you in my introduction, that we have almost got rid of the physical security people and we are able to manage security installations. So security as a system is managing on its own. Beyond that, I cannot comment on what you mean by a self-managed system. If you're talking about a security system, it can manage on its own.
Okay.
Okay, thank you. Yeah.
Self-managed versus centralized.
Okay, you're talking about individual controlling a system against a centralized system. Am I right? Have I understood it properly?
Individual controlling his or her own security. Basically, it's decentralized.
Yes, that's what is happening in home security. So if you look at foreign countries, When people enter the home, they've got a panel in which they enter a specific code, which is known to the individual only. Nobody else is knowing. So I can manage my security inside my house. I can give relevant passwords. I can control my devices which are there in my house, and I can do it on my own. I don't have to depend upon the outside structure, outside centralized structure.
Can the individual seek his own privacy against a centralized system?
Individual having his own privacy against a centralized system is a big question, which is difficult to answer that way straight away. Because when we talk about a centralized system is not going to peep inside your house unless otherwise it is required. So individual always can maintain his privacy. So the rest of the system, what the individual have inside his house is within his control. So he can manage it the way you want. Like I told you about that privacy masking. Suppose you put your camera in a room and certain areas you don't want to be seen, you can always mask that area. So that level of privacy can be maintained by an individual inside his house. But we talk about a centralized system. The centralized system is only monitoring the devices which are kept outside. Because I am as an individual, I'm not part of the centralized system. I am having my own system if I'm trying to use it that way. But when I am in an office, I'm part of the centralized system. There the camera which is monitoring me is part of the centralized system. So I may be seen. There I cannot have my privacy. But inside my home, inside my establishment, but things are under my control, I can always have a privacy and a control.
Okay. Sorry, Manikar sir, we will.
Thank you.
If you want, we can have a discussion privately. Sumaya, next, please.
Yes, sir. Thank you so much, sir, for those words of wisdom. Now let me welcome Suhair A, sir, to propose the vote of thanks.
No, this
Sir,
course
please.
You invite course P. You invite course P. Course P. Please.
Yes, yes, sir.
Yes, sir.
Yes, sir.
I welcome
Okay.
Kothwagi, sir, to give the vote of thanks.
Okay, Pratap Kumar sir, it's an interesting talk on this security system. Because there was so many questions and there were so many things to discuss, but as the time is over, I think we can discuss later on personally or something like that.
You can send me an email, I can answer your questions.
Yeah, I will do it. Because now a lot of surveillance cameras are available in Chinese and everything is available which can be connected to a network.
Yes.
But one thing is what we came to know that these all are Chinese equipments and it is network. So when it is connected in our house, all images are going to their server in China. And a lot of hackers are there. So these type of cameras will have an havoc for your house and your security. That is what I came to know. Okay, let us discuss everything later on. But you have nicely narrated the various type of alarm systems, and even you have given an eye into the global security market also, and given an opening for us to think on the future of the IEEE. Future of the security systems also. On this time, I take my opportunity to thank you for taking such a time, and that too from Bombay. As you mentioned, I heard that in Bombay it's really heavy raining and all those things. At this time, you have given us an excellent talk and you have treated us very well. Thank you, sir, for your thing. Thank you, Pratap Kumar.
Thank you very much. Thank you.
In the meantime, I extend my thanks to all the organizers, Jamanlal and his team, for organizing this in a nice way. And I extend my thanks to all participants and all the organizers and who all are involved in this one. Thank you a lot and thank you very much. Thank you.
Thank you once.
Thank you, sir. Now, I would like to inform you all about our 62nd talk, Diabetic Retinopathy by Dr. V. Indira, MBBS, Senior Consultant Ophthalmologist, which is to be conducted on next Wednesday, 16th of June, from 6 to 7 p.m. Hope to see you all next Wednesday. I request all our dearest attendees to kindly take a note and register for this session. Thus, we have come to the end of today's session. Thank you all.
Thank you
Meeting
once
is now
again. Thank you to all of you for patiently listening to me. Have a good evening. Have a nice day.
Great. Thank you.
Bye.
Bye.
Thank you, Pratap. Thank you for the great.
Thank you, Pratap.
Thank you, sir. Thank you. You have been a great help. You have been an inspiration to me. You have been a guidance to me. So you and Son together, I should say special thanks, of course, anytime.
Okay, have a great time.
Okay. Thank you, sir. Thank you very much.
Everyone, see for the next talk, diabetic retinopathy next Wednesday, 16 June. Have a great day. Have a great night.
I am a diabetic. I will attend.
Thank you very much. Thank you.
Okay.
Thank you for a great session.
Thank you.
Thank you. Thank you very much, sir. Gifty, you can close it.
Sir, you can share my mobile and email to all
Yeah,
who have
yeah.
asked this question. Please share with them so that they can send their mail.
Thank
you once again.
Those who want some comments from the
Yeah. I've seen some comments in the chat box.
Please send the feedback.
Okay.
Please send their email through feedback. We will correspond.
Thank you. Thank you very much. Shall I take leave?
Yeah, Gifty, you can close it.
Okay, sir. I will.